Okay, I'm here with Ivan, and Ivan is a PhD student at Florida International University. And what he's been working on is on an autonomous catamaran that is equipped to do underwater mapping that, of course, takes advantage of GPS, GIS technology. But I'm going to turn the mic over to Ivan and let him explain the system to you.
Okay, so here we have our autonomous surface vessel. It is a catamaran style with pontoons, and it has an onboard computer that can allow us to program it with its given GPS track, and it'll follow the track autonomously, and at the same time move while sampling is occurring with any instrumentation that we decide to attach to the vessel. So for my application, we were interested in doing coastal mapping of the region of the water that extends just from the edge. So if we can understand and see how the bottom surface is mapped, we can then take these images and stitch them together and create these mosaics so that we can look into potential for coastal erosion correction and really understanding the types of bathymetric features that occur right on the coastline. So in our case here, we can attach an imaging sonar. Now these imaging sonars use high frequency and are high resolution, so you can get a very clean sort of map or image of the sea floor. And at the same time, when this vessel travels along its course and it samples at such a high rate, then effectively you can get these images that are very high res that can map the bottom of the floor. And once you stitch them together after georeferencing them based on the GPS that's located on board on the vessel, you can then stitch them together and put them on top in a GIS system and visualize on an actual map how the bathymetry of the coastal line occurs. This is a small motion detector that has an accelerometer inside that runs off of a small microcontroller, and it can detect changes in two rotational axes. So in this case it would be the roll axis and the pitch axis. So here in the example, when we run this, you can see that as you rotate here in the pitch axis, you can see the plot change a little bit, and you can see the sensitivity in the roll axis as well. So in this case, this allows for motion correction so that when we plot the GPS tracks in the navigation part of the vessel, as it's moving, it will automatically correct based on changes in pitch and roll depending on any type of environmental conditions, and stay adhered to the proper GPS track that we input as well.